understand.
And now, sir, like the behavior of a graph, is it not supposed like to cut the graph, the three equal parts, like the polynomial, the way the polynomial behaves? In this case, it seems like it's going straight. How is it?
I don't argue with numbers. So look at this one. Y is equal to x to the power 3 minus x. Solution. The first thing we do here is we find the y-intercept when x is 0.
Sorry, sir. Yes, I just want to ask the topic we are looking at. Sorry, I joined late.
Okay, we are looking at applications of derivatives centered on sketches.
All right, thank you very much.
Okay. So when x is equal to 0, we get y is 0, 3 minus 0, which is equal to 0. So the y-intercept is 0, 0. Then we go to the x-intercepts. X-intercepts, you equate the function to 0. Factor out x, you have x squared minus 1 is equal to 0. So you get x is 0, or x squared minus 1 is 0, which gives us x is equal to 1, or x is equal to -1. These are the x-intercepts. X-intercepts and y-intercept. Okay, so we have the y-intercept, we also have the x-intercept. What don't we have? We don't have the turning points. We now want to bring in calculus to find the turning points. You get y prime. You differentiate the function y, you get y prime, which is 3x squared minus 1 using power rule. And then equate the first derivative to 0. So solve y prime is equal to 0. For us to get the values of x, that gives us the y values to form the points that are called turning points. So we equate 3x squared minus 1 to 0. Take 1 the other side, we'll have 3x squared is equal to 1. Divide by 3, divide by 3. So x squared is equal to 1 over 3, square root. So we get x is plus or minus 1 over root 3. The question is not that complicated for us to go to synthetic division. It can easily be treated as a quadratic after you factor out x. You only use synthetic where you don't know the factors. So you try to get a factor and then you can't easily get the other factor. So you use synthetic division. Okay, so these are the values of x that are going to give us the y coordinates for us to have 4 points. So when x is 1 over root 3, you go back to the function y, and so for y when x is 1 over root 3. What is this to the power 3 minus 1 over root 3? This is equal to 1 over 3 root 3 minus 1 over root 3. We can simplify this by getting the common denominator. If that is simplified, maybe it is simplifying, let's see. So we'll have 1 We have 1
So we
minus
can't hear you. I can't hear anything. Me, I can't hear you, sir.
I think it's your network. Try to dip and come back. So that we get -2 over 3 root 3. We also substitute. We also find y when x is -1 over root 3, the power 3 minus 1 over root 3. So we get -1 over 3 root 3 plus 1 over root 3. This is going to give us 3 root 3, giving us -1 plus 3, which is 2 over 3 root 3. So we have the turning points. So turning points, 1 over root 3, comma, -2 over 3 root 3, and -1 over root 3, comma, 2 over 3 root 3. And then we can sketch the function. How many turning points how many intercepts we have? We have 3. -1, 0, and +1. With the y-intercept being the y.
Yeah, it's the one.
So the y-intercept is 0, 0. So this 0, 0 is the y-intercept and the x-intercept. Then another x-intercept here, another one here. We found them by solving. Okay. Then now we also have turning points. -1 over root 3, comma, +2, 3 over root 3. We also have 1 over root 3, comma, -2 over 3 root 3. So we have a turning point here, another turning point there, meaning that our graph is going to be of this shape. Turning there, coming to 10 here, and then it goes up. Have you seen how we find the turning points? We did.
Yes, sir.
We sketched polynomials before calculus. The only thing calculus is adding, it's telling us the turning points. We didn't know how to get the turning points. Calculus has just come to fix that gap. Everything else must be understood under the topic polynomials. When you get to calculus, you just add the turning points, which you didn't know. So how to sketch, it must not be a question of today. Today, the question is how to find the turning points. That's what we call applications of derivatives.
Sir.
Hello?
Yes, sir. This is the last question ever because I know now to draw the graph. Now I just want to ask about the 0,0. Is it this one that where the graph has passed at the middle there?
Yes, 0,0 is always at the center of the XY plane.
Is that the same y-intercept that we found at first when we started the calculations?
Yes, and it's there as the y-intercept.
Okay. So we normally do that every time we are trying to graph a polynomial.
Yes. No,
Okay.
not just a polynomial, every function.
Every function.
For you to know the y-intercept, you
Okay.
let x be 0.
Okay.
So that's how you get the intercept.
Sir,
Mhm.
sir, are you going to finish that question you had started in class for the gradient?
Now bring a new one.
Sir.
That one is for you. Here's the new one.
Sir.
One. B find the equation of the norm. To the curve y is equal to x squared minus 9 over x. At a point 3,6, expressing it in the form ax plus by plus c is 0, where a, b, c are constants. Remember on Sunday of exam 1, and this is the language that you're going to have.
Around what time, sir?
14 hours, 14 to 17 hours. The normal time of writing exams. And this is going to be the language. Solution. The line has an equation y is equal to mx plus c, or y minus y1 is equal to mx minus x1. Any equation you use between these two, you get the equation of a line. When they say normal or tangent, your first task is to find the m. M is called the gradient. The gradient is found from the first derivative. We call the first derivative as the gradient equation. So the first derivative is called the gradient equation. It is the equation that gives us a gradient. So without the first derivative, we can't find the gradient in this case. So now we get our function y, x squared minus 9x to the power negative 1. I can write it as x to the power negative 1 because the x is in the denominator. So if I push it up, its power is going to be negative. Then now I differentiate using power rule. 2x minus 9 multiplied by negative 1, x to the power negative 2. Since you subtract, this is 2x plus 9 over x squared. I can push back the x now that I'm done differentiating. Then you equate the first derivative to 0 if you don't have this point. And you are told that m is 0. Now here we are looking for m. So in the first derivative, you get the value of x from this point. It is 3. Where there is x, substitute that number 3. Substitute the number 3. We'll have 6 plus 9 over 9, giving us 6 plus 1, which is 7. This 7 is called mt. Mt meaning the gradient of the tangent line. But we are asked to find the gradient, the line of the equation of the normal. So if it's the equation of the normal, then you multiply the gradient of the tangent multiplied by the gradient of the normal gives us -1. Since we have a gradient of the tangent, which is 7, what is the gradient of the norm? We divide by 7, we divide by 7. So you get the gradient of the normal is -1 over 7. This is the gradient that we take in the equation here or here, since we are looking for the normal line. So if we use
So why did you get -1?
So I said that when you multiply the gradient of the tangent and the gradient of the norm, you get -1. So where did I get the gradient of the tangent? The gradient of the norm. That's a standard equation.
Oh, all right, thank you.
Now that we have the gradient of the normal, whose equation we are looking for, then we go back to y is equal to mx plus c. And where there is m, we have the m now. It is -1 over 7. To find c, you use the point given. You use the point given to find c. Where there is x, you take 3. Where there is y, you take 6. For us to find c. So now,
Sir,
hello?
the one for the normal and the turning point is like a formula. It's just like that. It's equal to -1.
Ask the question properly.
The one for
For the normal
tangent
and the tangent.
and yes, it's like a formula.
Yes.
Oh, okay, thank.
Yeah. So now,
Sir,
put okay. So we take this the other side. So we have 6 plus 3/7 is equal to C over 1. So we'll have 7 down and 7 times 6 is 42. 42 plus 3. So we'll get 45/7 as C. So the equation is going to be y is equal to -1/7x plus 45/7. We've been asked to leave it in this form. So we'll multiply throughout by 7 so that we multiply throughout by 7 to avoid the denominator. And this is going to give us 7y is equal to -x plus 45. Then we arrange it in the required form. So we have x plus 7y minus 45 is equal to 0. This is the equation of the line called normal line to the curve at the point 3,6.
sir,
Yes.
well, I remember doing this in grade 12, sir. Mine changes to Gagono.
That's the same thing you are doing. Even at get 12, you are differentiating.
Yes, sir. Even integrate.
So why have you taken the speeds that you are moving with in the draw?
You also destroyed it.
Go
You left
back.
your ancestors behind you. You should have carried your ancestors.
Unja boy Isaac knowledge ishara forgets baragawangira bo chapa.
Yeah, I didn't know
Awe
that
boy,
confidence.
alishiyo omupashu, alishiyo omupashu.
Find me outside.
Another question.
Boy, 6 points karashara forget.
Sorry. Sir, can you explain some on the last part where how you got x plus 7y minus 45 equals 0?
So I've taken this side, this side. So what is negative becomes positive. What is positive becomes negative. So you take x to the left, 45 to the left of the equal sign. Do that. Another question. Okay. Questions done. This is a very, very good thing, showing that there is concentration and understanding. Wonder. Now that that is the case, another question of the same weight. This was B. Where was A? Okay, A was here. B. Okay, now there's no I can be saying C under a different. Let me say question 2. Find f prime of x. f of x is equal to e to the power 4x multiplied by 3x squared minus 5 to the power 6. B x squared plus sin y minus y squared is equal to 7. So let's start with A. If you have a function y is equal to e to the power u, if this is the function that you have, where u is a function of x, to find the derivative y prime, you differentiate u, then multiply by e to the power u. That's how you do the differentiation there. So that in this question, we have a product. So we use product rule. Let u be equal to e to the power 4x and v be equal to 3x squared minus 5 to the power 6. What is the derivative of u? You differentiate the power of e. Derivative of 4x is 4. And then multiply by the whole e to the power 4x. The derivative of v, you drop the power 6, multiply by 3x squared minus 5 to the power 5. And then you go inside and differentiate the inside. We get 6x. Then, to find f prime, we have u prime v plus v prime u. U prime is 4 e to the power 4x. V is 3x squared minus 5 to the power 6. Plus v prime, 6 times 6 is 36x, 3x squared minus 5 to the power 5, multiplied by u. U is e to the power 4x. Then we do b. B is x squared plus sin y minus y squared is equal to 7. Since we can't solve for y, we use implicit method, implicit differentiation. So we differentiate x squared, we'll get 2x. We differentiate sin y, we get cos y. But because we have differentiated y, we write dy dx. We differentiate y squared, we get 2y, but because it is y, we write dy dx. Differentiate 7, we get 0. Now we are solving for dy dx, so we'll take this 2x the other side as we factorize dy on the remaining parts. So dy dx, then we'll have cos y minus 2y. Hello?
Sir, that the implicit differentiation, you only do it when there's a y in the equation.
Yes. And then divide by cos y minus 2y, divide by cos y minus 2y. So we cut this. So we have dy dx is equal to negative 2x over cos y minus 2y. Any questions? No questions? Okay.
Sir,
Yeah.
what for another example on finding the equation of the solution?
All right. So many of them are there on time.
Sir, 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 maybe I missed. Did you by any chance do the how to find the local and the local minima and the points of inflection and so on? I'm worried.
I don't understand that. By the way,
Did you, sir, did we do that that subtopic where you find the local local minima and local maxima and the points of inflection?
But we just found the point of inflection in the last exam.
Sir, let's say we had the 6 functions in B. Can implicit method work?
Can
implicit method work if you had 6 functions? Let's say we had cos x squared plus sin y, cos x minus sin y squared is equal to 7. Can it work?
It can. It works. That's the way.
This time makes sense. When you're doing it this way.
Okay, so we log out and quickly come back. Serious business.
This used to be 5. Again, we multiplied by 6x. I don't understand that.
So don't take time to log back.